Hello, my name is Abdullah, and this is my second assignment. And the assignment consists of two parts. First task asks us about Bayesian network, and the second task, flight cancellation prediction, about using logical reasoning and probability. So in the first part, as I said, in the first task, uh, in the first task, I model a family using Bayesian network. And each person in the model has two variables: a gene variable, which can be 0, 1, or 2 copies, and a trait variable, which can be true or false. And parents' genes influences the child's genes, and the gene count influences whether the person expresses the trait. And the model uses predefined probability table called props. And here, this includes the unconditional gene distribution for people without parents, and the probability of expressing a trait given the number of gene copies, and the mutation probability. So, uh, actually, the most important function here is the joint probability. So the joint probability calculates the probability of one complete scenario, meaning who has 0, 1, or 2 genes, and who expresses the trait. For example, if a person has no parents listed, I use the unconditional gene probability. And if the person has parents, I calculate the probability of inheriting a gene from both mother and father, and taking mutation into account. So the update function here, it adds each computed joint probability into the correct distribution bucket for each person, both gene and the trait. And the normalize function here, this function ensures that each probability distribution sums to 1, and so the final results are valid. So finally, the program loops through all possible gene and trait combinations, checks the known evidence, and accumulates the joint probabilities, and normalizes the results to produce the final distribution. For example, we can see it. Oh no, wait. Here. So this is our output here. Let's go into the second part of our task. In this task, here. So in this task, it's about flight cancellation prediction, and my goal is to predict flight cancellation using a knowledge-based agent, combine it with probabilistic reasoning. So the dataset contains 10,000 flights, and the target variable is cancelled. And first, I construct a knowledge base using logical rules, and the dataset doesn't include a direct weather condition column. Yeah, but it contains a column called cancellation code, which indicates the reason for cancellation. I use this as evidence and define the following logical facts. So, for example, code B represents weather cancellation, and code C represents traffic or NAS related cancellations, and code A represents carrier operational issues, and code Z represents security issues. And if any of those codes appear, they logically then logically the flight is cancelled. And next, I calculate the unconditional probability of cancellation. So P cancelled equals the number of cancelled flights and divided by the total number of flights. So in this data set, it is approximately 0.0242, meaning about 2.4% of flights are cancelled. Then I compute conditional probabilities of cancellation reasons given that a flight is cancelled, such as, for example, P weather reason when given cancelled. Yes, P weather reason cancelled, and P traffic reason cancelled, P maintenance reason cancelled. So this helps identify which reason are most common among cancelled flights. So I also here applied Bayes theorem, and since cancellation code exists only when a flight is already cancelled, observing a weather cancellation reason directly implies that the flight is cancelled. Therefore, Bayes probability P cancelled equals 1. And this is expected because cancellation code actually represents evidence after the event, and not a predictive feature. The next one is actually hybrid AI system, and the final system is hybrid. Logical reasoning handles deterministic cases. When the cancellation reason code is known, probabilistic reasoning handles uncertain cases when no cancellation reason is available. For example, here, if the reason code is B, for example, the agent immediately predicts cancelled using logic. So if the reason is unknown, the agent uses the base probability of cancellation and predicts not cancelled. So since cancellations are relatively rare. So in conclusion, I can tell that in task 1 I used a Bayes network to infer gene and trait probabilities, and the task 2 is actually combines logical rules and the probability and the Bayes theorem to model uncertainty and build an intelligent decision-making system. Thank you.